Flexural strength. Adequate strength of prestressed concrete member is not automatically ensured by limiting stress at service load. There is a reason for that. The service load that being used in the analysis of the prestressed concrete member itself is an estimated load, which is determined based on past experience or based on the recommendations by the relevant code. Such estimations is determined on basis of the likelihood and probability. The estimation itself is not accurate. The actual loads acting on the member may be higher or lower than the specified load. Also, some loads in nature are imposed load, which can be there and sometimes it is not there. Because of that, the actual load acting on the prestressed concrete member is not constant throughout its service life. It is more likely to fluctuate over the time during its service life. Sometimes the member may be subjected to critical loads. Sometimes there were no imposed load acting on the member. And the estimated loads are estimated on basis of the characteristic load. Against is cover the 95% probability of the cases. With that, there are still chances that the member is subjected to overloading conditions. Should the member be overloaded, significant changes in behavior result from cracking occurs. It is because when one or both the concrete and steel materials are stressed into inelastic regions before failure. It is noted that the overloading conditions of the prestressed concrete member is not preferable, and if we design the member properly, the chances of overloading is not high. Nevertheless, it is important for us to know the overloading conditions of the member. Upon cracking, there is a sudden increase in the steel stress, which is accompanied by an increase in concrete compressive resultant. Then, as the load increases further, the prestressed beam behaves more likely like an ordinary reinforced concrete beam. In short, a prestressed element, when being overloaded, cracks occur, and this will cause one or both the concrete and steel material to be stressed into an elastic regions before failure, and because of that, the prestressed concrete member behaves more likely like reinforced concrete beam. This table compares the reinforced concrete and prestressed concrete members. First, a typical reinforced concrete beam have no steel strength developed in the unloaded conditions of 0 kN load. However, for the prestressed concrete members, there will be stress, which will give it negative strength at the conditions of no external load. Then, when the member is subjected to external load, the member deforms and the strength in the steel increases with the load. Both the strength in the reinforced concrete and prestressed concrete increase with the load, and at the initial stage, the increment is proportional to the load. The only difference between the RC and PC is that the starting point of the strength. The starting point of the RC for the strength will be 0, while the starting point for the prestressed concrete will be negative. Next, we look into the yielding response. Normally, the steel in the reinforced concrete have definite yield plateau. That means there is a sharp turning of the stress strain curve and the yield point can be easily defined. However, for the prestressed tendon, there is no sharp turning point. The yielding develops gradually, and after the yield point, the stress strain curve still rises smoothly until the tensile strength is achieved, only that at a smaller degree of stiffness.